Hello everyone, welcome again to Milo e-learning. So today we concentrate on sequences, specifically numeric sequences. So now let's look at the set of numbers. We have 4, 8, 14, 20, and 26. Now when we look at specific numbers, we need to think, is it growing in a certain pattern? Is it getting bigger? Is it getting smaller? By how much is it getting bigger? So we need to ask ourselves these questions to find out how the pattern is growing, because we can see that the numbers are getting bigger and there must be a pattern for it to get bigger. Now let's see. What do I need to do to the 8 to get 14? So I can say 14 subtract 8 is 6. So I am adding 6 to get to the 14. Then I can say, what can I do to the 14 to get 20? So I say 20 minus 14 is 6. So 14 plus 6 gives me 20. So I can see here that my pattern is constantly being increased by 6. So 20 plus 6 gives me 26, and 26 plus 6 gives me 32. Now, we use a word to define this constant difference. So we say that it is called a constant difference sequence because the difference between the two consecutive numbers is always the same. Now, constant because the pattern is growing by 6 by each number, difference because the difference is 6, and sequence because it is a sequence of numbers. So it is called constant difference sequence. Now let's look at something different. We have 1, 3, 9, 27. Now you're going to ask yourself, what must I do to the 1 to make it 3? What must I do to the 3 to make it 9? And what must I do to the 9 to make it 27? So we're going to say, we can't add because the numbers are totally different. So we're going to multiply. So we're going to say 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So now we can see that the numbers are still constant because we are multiplying. It is a sequence because the pattern is increasing, but it is not a difference. So we say it is a constant ratio sequence because in this example, the pattern is increasing by 3 to get to the next number. Now, it is constant ratio when we multiply or divide, and it is constant difference when we add or when we subtract. Now, let's look at these examples. If we are going to find out whether it is a constant difference, constant ratio, or if it is neither constant difference or constant ratio. So the first thing we need to look at is the pattern. So you're going to ask yourself, what must I do to the 3 to make it 5? What must I do to the 5 to make it 9? What must I do to the 9 to make it 15? And what must I do to the 15 to make it 23? So 3 plus 2 is 5. 5 plus 4 is 9. 9 plus 6 is 15. And 15 plus 8 is 23. So the next pattern, we're going to say 23 plus 10 gives me 33. 33 plus 10 plus 12 gives me 45. And 45 plus 14 gives me 59. So here you can see that this pattern, the numbers is changing each time. So it is not a constant. It is neither constant difference and neither constant ratio. So let's look at B. We have 7, 11, 15, and 19. So you're going to ask yourself, what must I do to the 7 to make it 11? So we say 11 subtract 7 is 4. So we are adding 4 to the 7 to make it 11. 15 subtract 11 is 4. So we are adding 4 to 11. So we now know that our pattern is constant. We are adding, so we know it's a constant difference sequence. So 15 plus 4 is 19. 19 plus 4 gives me 23. 23 plus 4 gives me 27. 27 plus 4 gives me 31. So it is called a constant difference because we are adding. Now let's look at C. We have 1, 2, 4, 8, and 16. So what will we do to the 1 to make it 2? What will we do to the 2 to make it 4? What will we do to the 4 to make it 8? And what can we do to the 8 to make it 16? So we're going to say 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Now another way of doing it is we can say 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So this way we are using the inverse operation to find out our rule. So our rule here is times 2. So each time we are timesing 2 to make the sequence. Okay, so let's say we say 16 times 2 is going to give me 32. 32 times 2 will give me 64. 64 times 2 will give me 128. So we say it is a constant ratio sequence because we are multiplying. Okay, now let's look at 729, 243, and 81. So we said we're going to take 729 divided by 243 and we are going to get 3. So here the ratio sequence between each one is dividing by 3. So we're dividing it by 3 each time. And let's say we say 81 now divided by 3, we'll get 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And this too is called a constant ratio sequencing because we are dividing. Hope you enjoyed my lesson. I'll see you in my next video. Enjoy the rest of your day. Bye everyone.